Okay, so let's look at how to make this a distributed process. So in the previous slide, we had multiple versions of order management systems. So what we are going to do is we are going to break the system into three more systems, or three individual systems or services, however you want to call them. So what we're going to do is we're going to create a new service called validator and processor and notifier. Each of them is going to do the same thing that we saw before: validation, processing, and notification. So what is going to happen is the validator is going to go and pick up the message from the queue, and then it's going to do its validation and then send that to the send a message into the queue, the processing queue, and the processor will pick up the message from there, and then that's going to send the message into notification queue, and then the notification queue is a notification service is going to go look at the notification messages in the notification queue, and then it's going to send it to the user. So we can scale this independently. Say for example, um, if your validation is for example takes 1 second, and if your processing is taking 5 seconds, for example, then you can have more of these and less of these. So you can scale things independently according to your individual specifications. So that's where distributed computing plays really well. Okay, so let's look at the benefits now. So by splitting order management system into three different systems, we still haven't reduced the time it will take to place a single order from 3 seconds. We may have actually introduced a slight delay because we have introduced additional queuing, so there may have been slight delay, but most likely it won't be noticeable depending on the queuing system that you are going to be using. So what it would give us is all three systems will perform efficiently because we have the capability to dynamically scale them, and no system will have to wait or do something else while the other system can actually do something. So let's take the example I gave before. So let's say the validator only takes 1 second, and the processor takes 5 seconds, and the notification only takes half a second, which is more likely what will happen in a real world scenario. So in that case, you will only need one notification, or like you can only have like two validators, for example, and then you can have 5 times as much the processor. So that way you're basically scaling the processor higher than the validator, and the notification service only needs 50% less resource or less instances than the validator service. So you can dynamically scale things up and down depending on the requirement. Plus, sometimes your order system will have to work harder, and then sometimes your order system will have to work doesn't need to work that hard. For example, on holiday season, you might receive more orders, and then rest of the year you might not receive that many orders. So this distributed system gives you the flexibility to scale up and down depending on your needs. So in terms of scaling, there's two types of scaling. So one is the horizontal scaling and one is the vertical scaling. So in terms of distributed computing, you can achieve both. But in terms of parallel processing, we will always do the horizontal scaling, which means multiple instances of the uh, same system or same service, however you want to call that. Okay, so how are we going to achieve this in C# or in Java or any other language that you prefer? So one of the standard that we have, one of the architectural design we have is called service-oriented architecture. It's an architectural pattern which helps create a distributed system. Basically, it has tons of requirements to be a system. It has tons of requirements to qualify as a service-oriented architecture. So among them, the most key thing is it has to be a discoverable service, which means you should be able to find that service and what it does. And then it must be scalable. So you should be able to scale up and down as and when you need it. And it has to be available. So it can't just go down. It has to basically you can have a lot of fail safes in there. And then it has to be loosely coupled with one another. So there should not be any hard reliance between one service and the other service. So the way to achieve server, we have something called message-oriented middleware. So this is one of the mechanism we can use to achieve service-oriented architecture. So think of message-oriented middleware as a platform or a technology to achieve truly server service. So there are a lot of platforms that offers this. So one such is called Rabbitmq, which you may have heard of, and the other one is Azure Service Bus, among two popular ones.